Welcome back to my YouTube channel. Today we will discuss one-step subgroup test and its proof and an example related to the test. Okay, first of all, what is one-step subgroup test? One-step subgroup test is say that any group G and H is a non-empty subset of G if A, B inverse belongs to H whenever A and B in H, then H is a subgroup of G. Okay, let's start the proof. First of all, the operation of H is the same as that of G. Okay, so this implies the associativity hold. Associative automatically hold. Okay, now next we show that next we show that identity belongs to H. Okay, since H is non-empty. Okay, so let A equal to X and B equal to X, also X. Okay, belongs to H, and in the hypothesis we have A, B inverse belongs to H. Okay, here if A, B inverse belongs to H whenever A and B belongs to H. Okay, so we claim here we choose A equal to X, also B equal to X. Okay, because H is non-empty, so at least one element belongs to H, so this is my X. Okay, and A and B equal to X. So by hypothesis here A, B inverse also belongs to H. Okay, so we have X and X inverse belongs to H, and this is equal to E identity. X dot X inverse is identity, so also belongs to H. So this implies identity element belongs to H. Okay, so two conditions already hold. Okay, for group theory, for groups. Now next, inverse. Next we verify that X inverse also belongs to H for every X belongs to H. Okay, so next, so that every element has an inverse. Okay, here we choose A equal to identity, already identity belongs to H, and B equal to X. Okay, now by again hypothesis we have A dot AB inverse belongs to H. Okay, so this implies identity and X inverse belongs to H, and this implies X inverse belongs to H. Okay, so here every element in H has an inverse, also hold. Now next we will prove H is closed, then proof is done. Okay, now we only show that X is closed, then proof is done. So now, next we show that H is closed under operation. Okay, so let X and Y belongs to H. Okay, so we already show that Y inverse belongs to H. Okay, every element has an inverse. Already show this from here. Okay, this property. So now we choose A equal to X and B equal to Y inverse. Okay, now this implies A, B inverse also belongs to H by again the hypothesis or statement of the test. Okay, so this implies X, Y inverse belongs to H. So this implies X, Y belongs to H. So that is H is closed. Here X and Y is arbitrary. So here H is closed. So proof is done. Therefore H is a subgroup of G. Okay. Now an example. Let G be an abelian group. Okay, with identity E. Okay, and define H is a subset set of all X belongs to G such that X square equal to identity. Okay, so now we show that H is a subgroup of G using this test, one-step subgroup test. Okay, so first of all we show that H is non-empty. Okay, now so first we show H is non-empty. How? Since identity this equal to E square, this equal to E identity. Okay, so this implies identity element E belongs to H. Okay, because H is a those of element of G which X square element square equal to identity. Okay, so this is hold. So this implies identity element belongs to H. Okay, here X square is a X dot X, that is here dot is operation. Okay, according to the question. Okay, so now next we show that any AB belongs to H, then AB inverse belongs to H. So then we say that H is a subgroup of G. Now here AB belongs to H, that is A square is equal to identity and B square is equal to identity by the definition of H. Okay, so now AB inverse whole square. Okay, now this, if this equal to identity, then AB inverse belongs to H. Okay, so now this equal to AB inverse dot AB inverse. Okay, and G is abelian. So every element of G, X and Y belongs to G, we have XY is equal to YX by abelian property. by definition of abelian group or abelians. Okay, so B belongs to H, so this implies B also belongs to G, and B inverse also belongs to G, and A already belongs to G. So we have, by abelian property of the group G, AB inverse equal to B inverse A. Okay, so from this A, these two elements B inverse A inverse commute each other, so this implies A B inverse dot B inverse. Okay, that is A square, and that is B inverse whole square, that is A square and B square inverse. From this this equal to identity into identity inverse, this equal to identity into identity, this equal to identity. So therefore AB inverse whole square equal to identity. So this implies AB inverse belongs to H. So hence H is a subgroup of G. Okay.